Hi students, in class 6 you learned about different types of motions. You learned that a motion could be along a straight line, it could be circular or periodic. Here are some examples. The motion of the soldiers in the march past is straight. The motion of bullock cart moving on a straight road is also straight. Hands of an athlete in a race is periodic. The pedal of a bicycle in motion is circular. The motion of the earth around the sun is circular. Motion of a swing is periodic. Motion of a pendulum is also periodic. We know that some vehicles move faster than others. Even the same vehicle may move faster or slower at different times. Make a list of 10 objects moving along a straight path. Group them, the motion of these objects, as slow and fast. How did you decide which object is moving slow and which one is moving fast? Look at this picture. It shows the position of some vehicles moving on a road in the same direction at some instant of time. Now look at the 13.2 picture. It shows the position of the same vehicles after some time. From your observations of the two figures, answer the following questions. Which vehicle is moving the fastest of all? Which one of them is moving the slowest of all? The distance moved by objects in a given interval of time can help us to decide which one is faster or slower. If you did not have a clock, how would you decide what time of the day it is? Have you ever wondered how our elders could tell the approximate time of the day by just looking at the shadows? How do we measure the time interval of month or a year? In olden days, people measured time with the help of natural events. Since they occurred at a regular interval of time, so there are many devices they used. The first one is sundial. A sundial worked on the principle that the position and the length of the shadow cast by an object changes with the position of sun in the sky. The sundials can be seen in ancient and medieval monuments like the one at Jantar Mantar in New Delhi. The next one is sand clock and the candle clock. If you see the sand clock, it works on the principle that a definite amount of sand takes a constant time to fall from the upper chamber to the lower chamber. This constant time was taken as the unit of measurement of time, which was called an hour. It is for this reason that a sand clock is also called an hourglass. Nowadays, the pendulum clock was also used to measure time. Galileo Galilei discovered that a swinging pendulum takes a fixed time to complete one oscillation. The to and fro movement of a swinging pendulum is called oscillation. So what is meant by simple pendulum? A simple pendulum means a metal bob suspended by a string by a fixed support and capable of oscillating in one vertical plane is called simple pendulum. So let us see how it is made. A simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. The metallic ball is called the bob of the pendulum. In this figure, you can see the pendulum at rest in its mean position, that is at the point A. When the bob of the pendulum is released after taking it slightly to one side, it begins to move to and fro. The to and fro motion of a simple pendulum is an example of the periodic or an oscillatory motion. The pendulum is said to have completed one oscillation when its bob starting from its mean position A, and it moves from B to C and back to B. The pendulum also completes one oscillation when its bob moves from one extreme point B to C and to the extreme position C and comes back to B again. The time taken by the pendulum to complete one oscillation is called its time period. So what is meant by the time period of the pendulum? The time taken by the simple pendulum to complete one oscillation is called its time period. So nowadays, the most clocks or watches have an electric circuit with one or more cells it is used. These clocks are called quartz clocks. The time measured by quartz clocks much more accurate than that by the clocks available earlier. Here you can see the stopwatch. The stopwatch is also used to measure the short time interval in the running competition or any events. Now we know that how to measure the distance that you have studied in standard 6, how to measure the distances, but here we have studied how to measure the time. So let's study how to measure the speed. So here in this picture you can see 4 persons are running. Who do you think ran the fast and who ran the slowest? We can calculate the speed of an object if we know the distance it travels in a given amount of time. So if a person covered 100 meters in 20 seconds, what is the speed? A speed is the distance traveled in unit time. The speed is find out by using the formula distance traveled divided by time taken. So if it is 100 meters covered in 20 seconds, then the speed will be 5 meters per second. So the formula and the definitions are: the distance moved by an object in a unit time is called its speed. In short, we can say the speed is equal to total distance traveled divided by time taken to cover the distance. Now let's consider that a car covers a distance of 100 km in 2 hours. So how to find out the speed? So the speed is equal to 100 km divided by 2 hours is equal to 50 km per hour. Now in this example, we can see from the question, the distance between Delhi and Lucknow is 500 km. So how much time will the bus take to cover the distance at an average speed of km per hour? So the distance between Delhi and Lucknow is 500 km. The average speed is 50 km. So the speed is equal to distance upon time. So from this formula we can calculate the time. So the time is equal to 500 km divided by 50 km per hour is equal to 10 hours. Now in the third example, you see a car moving at an average speed of 50 km takes 5 hours to complete. Find the distance covered. So speed is equal to distance upon time is equal to distance is equal to speed into time. Now you will get 250 km. Nowadays, the basic unit of time is a second. Its symbol is larger units of time are minutes and hours. You already know how these units are related to one another. Since the speed is distance upon time, the basic unit of speed is meter per second. Of course, it could be also expressed in other units such as meter per minute or kilometer per hour. So from this we learned the speed and how to measure find out the speed with the help of the formula. Then the units are kilometer per hour and meter per second. Now what is this? This picture is the speedometer and the odometer. So why it is kept in the cars and other vehicles? You might have seen a meter fitted on top of a scooter or a motorcycle. Similarly, meters can be seen on the dashboards of cars, buses, and other vehicles. So it shows how much kilometer it covered. That shows by the speedometer. That shows by the odometer, and the speed is measured with the help of the speedometer. So the speedometer and the odometer are kept in the car to find out the speed and the distance covered. Let's see now how this distance and time related. You might have seen the newspaper, magazines, etc. present information in various forms of graphs to make it interesting. This type of graph is the graph which is shown in the figure is the bar graph. Another type of graphical representation is a pie chart. The graph shown in this is an example of the line graph. So we can see the bar graph, pie chart, line graph. So let us learn how to make such a line graph. Take a sheet of graph paper. Draw two lines perpendicular to each other. Mark horizontal line XOX dash. Mark the vertical line YOY dash. It is called the y-axis. The point of intersection is O. The two quantities between which the graph is drawn are shown along the two axes. So x-axis along the OX is positive and OY is the positive marks on the y-axis. In this chapter, we shall consider only the positive values of the quantities. Therefore, we shall use only the shaded part of the graph shown in the figure. So, how to draw a graph? Draw two perpendicular lines to represent the two axes and mark them as OX and OY as in figure 13. Decide the quantity to be shown along the x-axis and that to be shown along the y-axis. In this case, we know the time along the x-axis and the distance along the y-axis. Choose a scale to represent the distance and another to represent the time on the graph. So in the horizontal line, that means in the x-axis, we have shown the time in minutes, and in the y-axis, we have shown the distance in kilometer. Now, mark the values for the time and the distance on the respective axes according to the scale you have chosen. Now, in this figure 13.2, we have got set of points on the graph corresponding to the positions of the car or any movement. Join all the points on the graph as shown in the figure. It is a straight line. This is the distance time graph for the motion of the car. If the distance time graph is a straight line, it indicates that the object is moving with the constant speed. However, if the speed of the object keeps changing, the graph can be of any other shape. Now, some of the points to be kept in mind while choosing the most suitable scale for drawing graph are the difference between the highest and the lowest values of each quantity we should know, the intermediate values of each quantity so that with the scale chosen it is convenient to mark the values on the graph and to utilize the maximum part of the paper on which the graph is to be drawn. Now, what are the uses of this distance time graph? The position of the object can be decided. The distance moved by an object can be decided. The speed can be calculated by obtaining distance covered in unit time. Whether the motion is uniform or non-uniform can be decided. Now, in this picture, we can see the motion of a person. Here a person walks equal distances in equal interval of time. So you can see at 2 p.m. to 3 p.m. the person covers 2 kilometers, and 3 to 4 again 2 kilometers. So thus equal distance is covered. Now in the next one, you can see 3 kilometer they have covered only one covered in only 1 hour. Like that, in the second, this one 3 p.m. to 4 p.m. it has covered only 1 hour. So we can say when a body moving along a straight line covers equal distances in equal interval of time, it is said to be in uniform motion. When a body moves unequal distances in equal interval of time, or it changes its direction of motion or the speed, then the body is said to be in non-uniform motion. So the motion can be of two. One is uniform and non-uniform. So here in this lesson we have studied what is meant by motion. Motion means a change in position of an object with respect to time with reference to the fixed point. Now then we have studied the speed. The speed is the distance covered by the body in an unit time. The formula of the speed is equal to distance traveled divided by time taken. The units of the speed is the kilometer per hour or meter per second. And then we had the distance time graph and the uses, and then we discussed the uniform and the non-uniform motion. So children, you read the textbook and try to find out the answers of the textual questions. Thank you.